I'm Anil Kumar, sharing with you an excellent question from my subscriber Irum. Irum, thanks a lot for enriching this YouTube channel with such beautiful questions. Now, this one on kinematics reminds me of one of my experience during morning walks when I was chasing a coyote. So we were on a different path, and I always wanted to see her eye to eye, and I was looking for a spot where we could be. So I'll share a part of that video also as part of this solution, and I hope that makes it more interesting. I never knew that mathematical models could work the other way. Well, let's get back to the question. The question here is, a particle x moves along a horizontal straight line so that its displacement s meters from a fixed point O t seconds after motion has begun is given by s equals to 28 plus 4t minus 5t square minus t cube. Obtain expressions in terms of t for the velocity and acceleration of x and state the initial velocity and the initial acceleration of x. The second particle, y, moves along the same horizontal straight line as x and starts from O at the same instance that x begins to move. The initial velocity of y is 2 meters per second and its acceleration a meters per second square t seconds after motion has begun is given by a equals to 2 minus 6t. Find the value of t at the instance when x and y collide and determine whether or not x and y are traveling in the same direction at this instance. Well, a lot of work to do here. So what we are going to do, we'll kind of break this up into a couple of parts, right? So first part, I will do this, that is to find out velocity and acceleration expressions for x, thereby giving you the initial acceleration, right? So that will be my first part. And then we'll look into y. And for y, we'll try to get the equations for velocity and displacement, right? And then it comes the third part, which is about colliding, when do they meet, and the fourth part is the same direction or not, right? So there are four things which are very critical to be found correctly to answer this question. So now let's begin one by one. First part is relatively simple. We are given the expression for displacement here, which is s equals to 28 plus 4t minus 5t square minus t cube. Now to find velocity, we just need to take the derivative, right? So you know velocity equals to ds over dt. So derivative of s. So we can write velocity as derivative of s, which is, so that is 0. If we get 4 minus 10t minus 3t square. Right? Now to get acceleration, we need to find derivative of velocity, since you know that acceleration is dv dt. So we can write acceleration as derivative of velocity, and that is minus 10 and 3 times 2, 6t. So we got the expressions for velocity and acceleration as function of time. So we've done this part. Now let's look into initial conditions. Initial conditions simply means what is the velocity and the acceleration when t equals to 0, right? So what we get here is that velocity when time is 0 is, substituting here, we get 4 minus 10 times 0 minus 3 times 0 squared, clearly 4 meters per second. As far as the acceleration is concerned, substitute. So we get minus 10 minus 6 times 0, which is minus 10 meters per second square. Perfect. So that is how we are going to do the first part of this. Now let's move on and analyze the second particle. So we'll try to figure out what is the equation for y. The initial condition of y is 2 meters per second. That is the velocity. So we'll write v0 is 2 meters per second. And its acceleration a is equal to 2 minus 60. Right. Now to get velocity from acceleration, we'll do antiderivatives or integration, correct? So either way. So since you know that integral of acceleration with respect to time will give us velocity, right? And we'll just use a very simple formula, that is if it is t, integral of t, let's say k times t, right, dt, then the integral is k times, let's say the power is n. In that case, integral will be, k times t to the power of n plus 1 divided by n plus 1. So you could either get it using integral or antiderivatives, either way, perfect, plus constant c, of course. Now this constant c we can always find from initial conditions, right? So this constant comes from initial condition. So from here we know what velocity is. So velocity at any particular time will be integral of acceleration, right? A times a dt. Now in our case it is equal to 2 minus 60 dt, correct? So we get 2, which is a constant. Integral will be 2t, and for minus 6t it will be 6t square over 2. So add a power and then divide by that, plus a constant, let's say c. So that becomes the expression for velocity. Now how do we find c? We are given that at t equals to 0, velocity is 2 meters per second. So if I substitute that, so we know that v of 0 is equal to 2, and therefore c is equals to 2. Perfect. So we get expression for velocity as 2t minus 3t square plus 2. Does it make sense to you? Right? So that is how we get velocity. And now we'll do antiderivative of velocity to get displacement. So the displacement will be, so I'm not writing this integral, which you understand by now, is basically, okay, let's write. So integral of vt with dt, and this is your expression. So it is integral of 2t minus 3t square plus 2, everything dt, okay. So that gives you, so basically we get 2t square over 2 minus 3 t cube, add a power, divided by 3 plus 2t plus some constant, so let's say k, right? So that is what is displacement expression. Now we are also given that it starts from O. So we are also given, which I didn't copy here, is that s of 0 is actually 0 since it starts from O, right? We are given starts from O, right? The origin. And the displacement is from O, and therefore this is 0. So k for us is 0, and therefore we can write the expression for displacement as, let me simplify this, we get t square minus, that also cancels, good job, t cube plus 2t, right? So that becomes the expression for displacement. So we have analyzed the second situation, particle y, and we got all the expressions needed. And now I think it is much simpler to solve this question. We can take a break here. You try it out, and then after the break, let's see the solution for the remaining part of this question. I hope you are enjoying it. So we have got the expressions for displacement and velocity. Let me push it forward so that you can clearly see them. And now the question is, when do they collide? Now the time when they collide will be when their displacements are exactly same. at a particular instance of time. So we have to work with two equations, that is displacement function of particle y and displacement function of particle x. So let me copy both these equations and then from there we'll continue. So now we are looking into find the value of t at the instance when x and y collide and determine whether or not x and y are traveling in the same direction. So for x, what is the displacement? Right? So we were given this function. For y, what is the displacement? We are given displacement as 28 minus 4 plus 40 minus 5t square minus t cube. And for y, we just found that this is equal to t square minus t cube plus 2t, right? So we have these two equations, and it is obvious that they are going to collide when these two displacements are exactly same, right? So we are trying to solve when is s of x and s of y equal. So that's the strategy. Perfect. So solving two cubic equations for the time being, so we'll just equate one equal to the other. So we can write this as 28 plus 4t minus 5t square minus t cube equals to t square minus t cube plus 2t, right? So, well, the cubic part cancels for us. That is very good. Now it's simpler to solve. So we'll bring the terms together and then solve them. Since this is negative here, we'll bring it to the right side. So we get 0 equals 2. We have t square plus 2t. Now we get 5t square here minus 4t and minus 28. So that gives you 6t square and 4t minus 2t, that means, and we have minus 28. We could actually take 3 common here, so we get 2 common here. So we get 3t square minus t minus 14 equals to 0. So let's see how to factor this and then solve. As far as sum and product is concerned, we're working with 3 times 14 with a negative sign, which is 42. So 42 is 6 times 7, right? 6 times 7 and 7 being bigger number, negative. So we could write this as 0 equals to twice 3t square and plus 6t minus 7t minus 14. Perfect. So we have 2 times 3t common, t plus 2 minus 7 common, t plus 2. So we get here 2 times, now t plus 2 is common, and 3t minus 7. So that gives you, this is t minus 1, which is not valid, so we'll just forget about this. However, that gives you a positive value. So we find that t equals to 7 over 3. By equating 3t minus 7 equals to 0, you can just solve for t, right? So t equals to 7 over 3. So we have found the time when they are going to collide. So let's say, so we know the time will be t equals to 7 over 3, which is 3 times 2, 1 over 3 seconds. Correct? So that part we have done. And now the last part, whether they are traveling in the same direction at this instance or not. So that was very interesting, coming back to my experience of chasing the coyote. Whether we were traveling in the same direction or not, well, you could find it after the end of the video. But now let's continue with this video and figure out whether these two particles were traveling in the same direction or not. Now we are in the last phase of our solution, and you need to find whether these two particles were traveling in the same direction or not when time was 7 over 3 seconds, rather when they collided, right? Which equation are you going to use? which equation will you use? So I've actually copied all these equations which we derived for displacement and velocity for particle x and y, right? So we have these two sets of equations. And we also have our time, right? So now how do you find whether they were traveling in the same direction or not? So the idea is direction is provided by velocity. So we'll check velocity. So if velocity has same sign, that means they are going in the same direction. Perfect. So we'll find the velocity of particle x when time was 7/3, and we'll also find the velocity of particle y when the time was 7/3. We'll just calculate using the calculator. If we get same sign, both negative or both positive, they are in the same direction. But if we get opposite signs, then they are traveling in the opposite direction. So that's the critical thing. So let's just substitute the values. So for the first, 4 minus 10 times 7 divided by 3 minus 3 times within bracket 7 divided by 3 square gives me a value which is minus 107/3, obviously meters per second. Now let's calculate for the second particle, which is velocity expression 2t minus 3t square plus 2. So 2 times 7 divided by 3 minus 3 times within bracket 7 divided by 3 whole square plus 2 is equal to minus 29/3, right? So both are negative answers. So both negative means that both of them are approaching the origin. Do you understand? So they are traveling in the same direction, right? Since both are negative, we'll say they're traveling in the same direction. So the answer is same direction. Is it okay? So the direction is approaching origin. Their starting point. So that is how we should be solving this particular equation, right? So it could be approaching, or it could be going away from this on the left side. Either way, since both the signs are negative, clearly it indicates that they are traveling in the same direction. Perfect. So I hope you enjoyed the solution and the way it has been solved. It was an excellent question. And Iru, once again, thanks a lot for posting, and the whole playlist on kinematics is all because of you. Thank you once again. For all of the subscribers, I'll encourage you to post questions, write comments, and share my videos with your friends. Thanks a lot and all the best.